Okay, so this will be the last lesson that we go over in chapter 2. And this lesson's actually, the section's not in our textbook, but it is something that is really important, not only for this class, but whenever we get into the calculus content as well. So we're going to take a look at solving polynomial and rational inequalities. And we're going to take a look at some things that we've learned in chapter 2 that can help us solve polynomial and rational inequalities more efficient. Now, I know we've done some examples with this. You guys had some problems that pertain to this stuff on your chapter 1 test, but we should be a little better equipped to deal with problems of this type now. So there are 6 examples that we're going to look at in total. We're going to do 3 polynomial inequalities, and then we're going to do 3 rational inequalities as well. So directions ask us to solve the inequality, and then we're asked to write the solution in interval notation. So for number 1, we have 6x squared is less than or equal to 6 plus 5x. So anytime we are solving a polynomial or rational inequality, our goal is to get everything moved to one side where we are comparing an expression to the numeric value 0. Okay, so I like having my squared term be positive, so I'm going to move 6 and 5x to the left-hand side by subtracting, and then I'm going to write the terms in descending order. So we get 6x squared minus 5x minus 6, and we want to find where that is less than or equal to 0. Okay, so what we want to do next is we want to find the zeros of our polynomial. And if you can factor, you want to factor. You may have to use quadratic formula, though, if your polynomial is not factorable. Or if you have a polynomial of degree higher than 2 that you can't use like factoring by grouping with, you may have to use Descartes' rule of signs and the rational zeros theorem to find the zeros of your polynomial. This polynomial here is one that we can factor. Just to do it real quick, I'm going to make my x. The number that goes on top is the product of the constant and the leading coefficient. So negative 6 times 6 is negative 36. Number that goes on bottom is the coefficient of the middle term, which is negative 5. And we are looking for 2 numbers that multiply to give the top number and add to give the bottom number, which are negative 9 and 4. So we're going to split that middle term up into 2 terms with those coefficients. So that's going to make 6x squared minus 9x plus 4x minus 6. And then we're going to factor that polynomial there by grouping. Okay, so when I look at the first 2 terms, the greatest common factor is 3x. Whenever I factor that out, that leaves me with 2x minus 3. And then I can factor a positive 2 out of the next 2 terms, which leaves me with 2x minus 3. So 2x minus 3 is our common factor. And when I factor it out, that leaves me with 3x plus 2. Okay, so what we want to do next is we want to take those 2 factors and find the zeros of the quadratic function. So the value that makes the first factor 0 is 3/2, and the value that makes the next factor 0 is negative 2/3. And we're going to put those 2 zeros in numeric order on a number line. Okay, so negative 2/3 is a smaller value. That's going to come first. 3/2 is the larger value, and that's going to come second. Okay, now, what we've done with this in the past is when we put those numeric values on our number line, that splits our number line up into 3 intervals. And then we tested values on each of the intervals to see whether the product was going to be positive or negative. Okay, so I can still do that. If I pick a value on the leftmost interval, let's say I pick negative 1, when I plug negative 1 in the place of x, that first factor is going to be negative. The second factor is going to be negative, so that resulting product is positive. I can pick a value on the middle interval. Let's say I pick 0. When I plug 0 in the place of x, The first factor is negative and the second factor is positive, so that resulting product is negative. And if I pick a value larger than 3/2, let's say I pick 2, the first factor is positive and the second factor is positive, which makes that product positive. Okay, that method's still fine, but I think we have enough of an understanding about polynomial functions where we can actually work through this a little bit quicker. Okay, so what we're going to do instead is all we have to do is pick one interval to test. And it doesn't matter which one you pick. Let's say we pick the leftmost interval. Okay, we tested the value -1 on that interval and we found that to be positive. What we can do now, which is more efficient, is we can look to the multiplicity of our 0. Okay, and again, the multiplicity dictates whether the sign touches or crosses the x-axis at that point. Okay, so our 0 of -2/3, that's the 0 of the highlighted factor. The multiplicity of that 0 is 1, so the graph has to cross the x-axis at that point. So if the graph crosses the x-axis at -2/3 and it's positive to the left of that x-intercept, when the graph crosses to the right of that x-intercept, the product is going to be negative. And then we can look at the multiplicity of the next 0. So the multiplicity of the 0 3/2, 3/2 is the 0 of the factor 2x minus 3. That has an exponent of 1, so that 0 has a multiplicity of 1, which means the graph crosses the x-axis at that point. So if the graph crosses the x-axis, the sign must change on the next interval. So that last interval would be positive. If the multiplicity of your 0 was even, that means the graph would touch the x-axis at that point, and the signs would then have to be the same on each side of that x-intercept. Okay, so it gives us a much more efficient way to interval test. And again, it doesn't matter if you pick the leftmost interval. You can pick an interval in the middle. You can pick an interval on the right. Like, it doesn't matter which one you pick. You're going to use the multiplicity of the x-intercepts to determine the signs on the subsequent intervals. Okay, so we're just trying to find where this product is less than or equal to 0. So it's less than or equal to 0 on the interval from -2/3 to 3/2. And because our sign is less than or equal to, we're going to use brackets at the 2 endpoints. So if it's less than or equal to or greater than or equal to, you use brackets for your endpoints. If your sign is less than or greater than, you're going to use parentheses. Okay, let's do the same thing with number 2. So for number 2, again, we want to move everything to one side. So I want the highest degree term to be positive. So I'm going to subtract 4x squared on both sides. And then I can factor an x squared out of the resulting polynomial, which gives me x squared times the quantity x minus 4 is greater than or equal to 0. Okay, so my two zeros are x is equal to 0 and x is equal to 4. So I'm going to put those in order on our number line. And I can pick any interval I want. So let's just pick the middle interval just for fun. Okay, so I'm going to test the middle interval. So I'm going to pick a value between 0 and 4. Let's say I pick 1. Now, I don't have to bother testing the first factor, x squared, because no matter what number I plug in the place of x, whenever I square it, it's going to be a positive quantity. So the sign of the product is going to be dependent on the value of the second factor, x minus 4. So when I plug 1 into that second factor, 1 minus 4 is going to be negative. Okay, so let's use the multiplicity of our zeros to find the signs on the outer intervals. So let's do the left one first. So when I look at the multiplicity of the x-intercept at 0, it's 2, it's even, which means the graph has to touch the x-axis at that point. So the signs on both sides of that interval are going to be the same. And if I pick a, well, I don't even have to pick a value. So when I look at the next x-intercept at 4, the multiplicity of that 0 is 1. It's odd. The graph has to cross the x-axis at that point, so the sign is going to change on that interval. So we're trying to determine where that product is greater than or equal to 0. Well, it for sure happens on the interval from 4 to infinity. But we're not done, because when I plug 0 into the function, that product 0 is greater than or equal to 0. So we have to include 0 on our interval as well. And a lot of you guys goof this up on your test. If you're writing a single number in interval notation, you have to use set braces for that single number. Okay, so that right there is how you would write the solution in interval notation to that polynomial inequality. Okay, I want you guys to try 3, and then pause the video whenever you're done. You can go ahead and check and see the solution to it. All right, so with number 3, I'm going to do 2 things to start. Number 1, I'm going to distribute 2 across both terms. And then I'm going to move negative 9 to the left-hand side by adding 9 to both sides. That way we can compare our polynomial to 0. Okay, so that's going to give us 4x squared minus 6x plus 9. We want to find where that is greater than 0. Okay, so we want to attempt to see if we can factor this. So to factor, I need to take the product of the leading coefficient and the constant term. So 4 times 9 is 36. That goes on top. The coefficient of the middle term, negative 6, goes on bottom. So I'm looking for 2 numbers that multiply to give 36 and add to give negative 6. And there are no 2 numbers for which that occurs. Okay, so that means that that quadratic function is not factorable. Okay, so if it's not factorable, we have to attempt to find the zeros in another way, which would either be completing the square or the quadratic formula. I'm going to use the quadratic formula because I think it's a little bit faster. So that would give us x is equal to negative b, which is going to be 6, plus or minus rad b squared, so negative 6 squared is 36, minus 4 times a, which is 4, times c, which is 9, all over 2 times a, which is 4. And we have a problem here because the discriminant, which is the argument of the square root function or the square root expression, is going to wind up being negative. You're going to have 36 minus 16 times 9, which I believe is 144. So if that discriminant is negative, that means that this graph has no x-intercepts. Okay, which means that the graph does not touch or cross the x-axis. Okay, now we need to think a little bit with this one. Okay, so if our graph has no x-intercepts, we have to look at how our quadratic function is going to open. And because the a value here is positive, that means that the graph is going to open up. So if the graph opens up and has no x-intercepts, that means the vertex has to lie above the x-axis. So if we're trying to calculate where that quadratic function 4x squared minus 6x plus 9 is greater than 0, that's going to happen everywhere because that graph always lies above the x-axis. So all real numbers are solutions. And we can write that in interval notation as the interval from negative infinity to infinity. Okay, so again, if you can't factor your polynomial, you may, or your quadratic function, you may have to use completing the square or the quadratic formula to find all of the zeros. Okay, let's move on to rational inequalities. So for number 4, we have x minus 3 times x plus 2 over x minus 1, where that is less than or equal to 0. Okay, so again, I want to be comparing my expression to the number 0. Okay, now the first thing I want to do here is I want to look at the rational function and figure out what the domain of that function is. Okay, so we know when we look at that rational function, our denominator cannot be equal to 0, which means that x can't be equal to 1. Okay, and we need to keep that in mind at the very end when we are constructing our intervals. Okay, so we're going to do the same thing that we did with the polynomial inequalities. We want to make sure the numerator and denominator are factored completely, which they are. And then we're going to list the zeros of the numerator and denominator in order from smallest to largest. Okay, so the smallest zero of either the numerator or denominator is going to be -2. The next smallest one is going to be at 1, and then the largest one is going to be at 3. Okay, now we want to test our intervals again. Now we're going to do the same thing as we did with the polynomial inequality to test the rational inequality. So I'm going to pick one of the intervals to test. Let's say I pick the leftmost interval. So I want to pick a value that is smaller than -2. Let's say I pick -3. So when I plug -3 into that rational function, the first factor on top is negative, the second factor on top is negative, and then the factor on bottom is negative. So on top, you get a negative times a negative, which is positive, divided by a positive divided by a negative number gives us a negative quotient. Okay, now we're going to use multiplicity again to figure out the signs on the subsequent intervals, because when we look at that rational function, x plus 2, that is the factor that has a 0 of -2. The multiplicity of that 0 is 1. Okay, so because that's the 0 of the numerator, it has a multiplicity of 1. That's an x-intercept. The graph is going to cross the x-axis at that x-intercept. So the sign has to change on the next interval. So that's going to be plus on the next interval. Okay, 1 is the 0 of the denominator. So we know that zeros of the denominator in lowest terms gives us a vertical asymptote. And then we can look at the multiplicity of that 0 in the denominator to figure out the behavior of our graph at the vertical asymptote. So we know because the 0 in the denominator has an odd multiplicity, that means our graph has to go in opposite directions at the vertical asymptote. So as we approach 1 from the left-hand side, the graph is positive. It's going to positive infinity. As we approach 1 from the right-hand side, that side has to go to negative infinity. Okay, so that interval is going to be negative. And then the last 0 of 3 is a 0 of the numerator. That's an x-intercept. It has a multiplicity of 1. So the graph has to cross the x-axis at that point, which means the sign changes on the next interval. Okay, so that was the explanation of why the signs change or remain the same. Really, all you guys need to be aware of is that if the multiplicity of your 0 in either the numerator or denominator is odd, the sign is going to change on the next interval. If the multiplicity of your 0 in either the numerator or denominator is even, the sign remains the same on the next interval. Okay, let's move on to the next one. So for 5, we have 3x minus 5 divided by x plus 2 is less than or equal to 2. Okay, step 1, we want to get our domain. So we know x can't be equal to negative 2. Now, if we were solving an equation here, so pay close attention, okay? If we were solving an equation, the way we would solve an equation like this is we would multiply both sides by x plus 2 to get rid of the fraction, okay? We cannot do that when solving an inequality. And the reason being is, since we don't know what the value of x is, I don't know what the value of x plus 2 is going to be. And if x plus 2 is positive, when I multiply both sides by a positive number, the sign of the inequality remains the same. But if x plus 2 is a negative number, then when I multiply both sides by a negative number, the sign of the inequality changes. So we don't know if I multiply both sides by x plus 2 to keep the sign of the inequality the same or to change the sign of the inequality. Okay, so we can't multiply both sides of an inequality by x plus 2. So what we have to do with a problem like this is we have to move everything to one side. So we get 3x minus 5 over x plus 2 minus 2 is less than or equal to 0. So we are comparing something to the number 0, and then I want to take that left-hand side and combine into a single fraction. So to do that, I have to get a common denominator of x plus 2. That first numerator will have the denominator x plus 2. The second one, negative 2, I have to rewrite that as negative 2 times x plus 2 over x plus 2. So I'm going to distribute, I'm going to have to go back. Sorry, I didn't even finish problem number 4. Let me finish this off real quick. Okay, so we have to figure out where that quotient is less than or equal to 0. So this would be on the interval from negative infinity to negative 2. And then again, because the sign is less than or equal to, we're going to use a bracket at negative 2. And then also the interval from 1 to 3. And we're going to use a bracket at those two values. But then we have to go back and check that against our domain. And we know that x cannot be equal to 1. So I have to remove 1 from that interval. So I'm going to change that bracket to a parenthesis. Sorry, guys, I forgot to do that. Okay, so that one's all done now. My apologies. Okay, so we'll jump back to number 5. So I want to go through and simplify the numerator. So I'm going to distribute negative 2 across both terms. So we get 3x minus 5 minus 2x minus 4 over x plus 2. And we want to find where that is less than or equal to 0. And then that numerator, when I combine like terms, is going to become x minus 9 over x plus 2. And we want to find where that is less than or equal to 0. Okay, so we're going to list the zeros of the numerator and denominator in order from smallest to largest. So those are negative 2 and 9 respectively. And then we're going to pick an interval to test. So this time I'm going to pick the middle interval because it's going to be the easiest one for me to test. I think the best choice to pick on that middle interval is the number 0. So when I plug 0 into that quotient, the numerator is negative, the denominator is positive, so that gives me a negative quotient. And because the multiplicities of both of those zeros, negative 2 and 9, are odd, that means the sign is going to change on those two intervals. Okay, so if we're trying to find where we are less than or equal to 0, that's going to be the closed interval from -2 to 9. But then we have to go back and check that interval against our domain here, and we know that x cannot be equal to -2. So I have to remove that value from my interval by changing that bracket to a parenthesis. Okay, I'm going to have you guys do number 6. So for number 6, you have x plus 12 over x is less than or equal to 7. All right, so pause the video, give that one a try, and then we'll work on it together. Okay, so again, step 1, find the domain. So x can't be equal to 0. Okay, step 2, we're going to move everything over to one side. So we're going to get x minus 7 plus 12 over x is less than or equal to 0. And then we want to combine the left-hand side into a single fraction. So that's going to have a common denominator of x. And then when I rewrite x with that denominator, that's going to be x squared over x. When I rewrite -7 with that denominator, that's -7x over x. And then we have plus 12 over x is less than or equal to 0. And then we can factor that numerator. That's going to factor to x minus 3 times x minus 4. Divided by x is less than or equal to 0. So we're going to take the zeros of the numerator and denominator and list those in order from smallest to largest. So that is going to be 0, 3, and 4. So what interval do you guys want me to test? I'm going to predict that you guys are going to want me to test the rightmost interval. So I'm going to pick the rightmost interval. So I'm going to pick a value bigger than 4. Let's say I pick 5. So the first factor on top is positive. The second factor on top is positive. The denominator is positive. So that's going to give me a positive quotient. And then I'm going to use the multiplicity to get the signs on the subsequent intervals. So the multiplicity of all of those zeros is 1. It's odd. So the interval to the left has to have a different sign. The interval to the left of that has to have a different sign. The interval to the left of that has to have a different sign. So if we're trying to find where that is less than or equal to 0, that's going to happen on the interval from -infinity to 0, union the closed interval from 3 to 4. And then again, we're going to check that interval against our domain, and we know that x can't be equal to 0. So I'm going to remove that value from that interval by changing the bracket to parentheses, thereby making that interval open. Okay, so that's it. That wraps up Chapter 2. You guys are going to have your test on Chapter 2 next week. Okay, so we'll see you guys in class on Monday. Take care.